If A vector, B vector, C vector are three vectors, then prove that box product of A vector plus B vector, B vector plus C vector, C vector plus A vector is equal to twice of box product of A vector, B vector, C vector. Here they are given three vectors and box product is nothing but which is scalar triple product. LHS is box product of A vector plus B vector, B vector plus C vector, C vector plus A vector. They are given three vectors. In first expression, C vector is missing term. Second expression, A vector is missing term. And third expression, B vector is missing term. Therefore, this can be written as A vector plus B vector plus 0 into C vector. Second expression 0 into A vector plus B vector plus C vector. And third expression A vector plus 0 into B vector plus C vector. So, இதுக்கு பேலன்ஸ்டா இது இருக்கும். Scalar triple product or box product can be expressed as determinant form. So, determinant of here common term for all the rows. First expression, second expression and third expression is A vector, B vector, C vector. That's why we can write into A vector, B vector, C vector, which means box product of A vector, B vector, C vector. This is theorem 6.6. Now, this is expression of row 1. Coefficient of A vector is 1, coefficient of B vector is 1 and coefficient of C vector is 0. And this is expression of second row. Coefficient of A vector is 0, B vector is 1 and C vector is 1. This is expression of third row. Coefficient of A vector is 1, B vector is 0 and C vector is 1. So, determinant எடுக்கிறதுக்கு முன்னாடி sign decide பண்ணிக்குவோம். This is plus, minus, plus. Expanding along R1, we get 1 into the related row and column delete பண்ணிருங்க. Remaining 1 into 1, 1 minus 0 into 1, 0. Minus of 1 into the related row and column delete பண்ணிட்டு பார்த்துட்டீங்கன்னா 0 into 1, 0 minus 1 into 1, 1 plus third element 0. So, அதனால அதை express பண்ண வேண்டியதில்லை. 0 into anything will be 0 into box product of A vector, B vector, C vector. So, 1 minus 0 is 1. இங்க 0 minus 1 is minus 1. இங்க plus 0 அப்படின்னு தான் இருக்கு. Which is equal to 1 into 1, 1 plus minus 1 into minus 1 is plus 1. Minus 1 into minus 1 is plus 1 into box product of A vector, B vector, C vector, which is equal to 1 plus 1 is 2. Therefore, 2 into box product of A vector, B vector, C vector. Therefore, box product of A vector plus B vector, B vector plus C vector, C vector plus A vector is equal to twice of box product of A vector, B vector, C vector. Hence the proof.